All right, so if the b squared minus 4ac is greater than 0, that means we'd have plus and minus a real number. So that would give us two real solutions. And so what would happen is, remember, a quadratic makes a parabola. Our parabola would look something like this. And we would have two places where it's crossing the x-axis, which is what's giving us the two real solutions. And they're unique, meaning they're different. If the b squared minus 4ac is equal to 0, we'd be taking the square root of 0. And the square root of 0 is just 0, right? So if I'm going plus or minus 0, does it change my answer if I take 3 plus 0 or 3 minus 0? No. So we're only getting one real repeated solution here. So we're getting two answers, but it's the same answer twice. And so what that would look like on a graph is that our parabola would just touch the x-axis at one place and move off. That's why we're only getting one solution there. It's just touching it at one spot. And if the b squared minus 4ac is less than 0, that would give us the square root of a negative, which we'd have to use imaginary or complex solutions for that. So that would give us no real solutions, because you don't get real answers from the square root of a negative, but we get two imaginary solutions. And so what the graph would look like that is that it wouldn't touch the x-axis. So it looks something like that. That's why there's no real solution, because it's never touching the x-axis. All right, so if the question would just say compute the discriminant, so like checkpoint 9 here just says compute the discriminant, and then determine the number and type of solution. Okay, so are we getting two solutions, one solution, or no real solutions? So if it just says compute the discriminant, remember the discriminant is b squared minus 4ac. So it would still have to, the equation still would have to be equal to 0. All of these are already equal to 0, so we're good. We still want to figure out our a, b, and c. So our a is 1, b is 6, c is 9. So b squared, we do 6 squared minus 4 times 1 times 9. That would give us 36. And then I have negative 4 times 1 is negative 4, times 9 is negative 36. So negative 36 minus 36 is 0. So essentially, again, we'd be taking the square root of 0, which is 0. So how many solutions would we be getting here? 1. So this would be one real solution is what we want to write here. For B, again, we're just writing our A, B, and C to start. A is 2, B is negative 7, C is negative 4. So B squared would be 7 squared minus 4 times 2 times negative 4. And so 7 squared is 49. Negative 4 times 2 is negative 8. Negative 8 times negative 4 is positive 32. And so we get 81. 81 is a positive number, and if we took the square root of 81, we would get 9, right? So we're going to get two real roots here. And they would be rational roots because you're taking the square root of a perfect square. If you got like, say, 50, square root of 50, there'd be real roots, but they'd be irrational because the square root of 50 or 50 is not a perfect square. And then last one, our a is 3, b is -2, c is 4. And so we have b squared, -2 squared. Be careful that the -2 is in parentheses, -4 times 3 times 4. And so -2 squared is +4. -4 times 3 is -12. -12 times 4 is -48. And so we get -44. We'd be taking the square root of a negative, so we'd get two complex roots for this one. All right, so take a moment and just try, let's see. Just try 77 and 81. Okay. Again, it's just saying compute the discriminant here.